We're going to look at circles slightly differently than you have in previous courses. An equation of a circle and how to write that from the given information. We're going to look at circles as a conic section. So those are shapes that are created by an intersection of a double-naped cone. So it would actually have two of these cones, vertex to vertex, and a plane. There are four types of conic sections: circles, which we see pictured here. We'll also look at parabolas, ellipses, and hyperbolas once we get into pre-calculus. So in this course, we're going to focus on circles, which are the cross section. So remember, a cross section is created when we slice through a three-dimensional object, and then we look at the two-dimensional object that's created. And a parallel plane, so a parallel plane to the base. So if you go back to the previous slide, you'll see that that plane is cutting that cone parallel to the base, and then that would create our circle. And so those sizes of the circles would change dependent on how close we are to the vertex of the cone. We take those cross sections and we put them on a coordinate plane so that we can write the equation of any circle that is centered at the origin or away from the origin with any radius length. So again, that's what changes as we move up and down the cone, closer and closer to that vertex. We change the radius. Remember, radius is from the center point to the outside edge. We talk about conic sections as a locus, so that's an equation that represents a set of points that are a constant distance, in this case it's the radius, from a fixed point which we call the center. Now, there's a general equation for all of these conic sections that looks like this: ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. We have to take and manipulate these equations, and not every conic section uses all of these terms, but we would change this equation so that we could see more specifically where the center of the equation, the center of the circle is, and the radius of that circle. Much easier. So the standard equation of a circle starts with Pythagorean theorem. And again, we think about this circle as having a center point in the middle, and then our radius. And we said that we can take and we can put every circle on a coordinate plane. So if we think about sketching in an XY plane, then we can start to think about where this equation comes from. So we would have our center, in this case we would be at 0, 0, and then we would have some point on the circle that we would call x1 and y1. And again, that's going to be a certain radius away. So we use Pythagorean theorem with this because we can create a right triangle. And then if we think about what Pythagorean theorem says, a squared plus b squared equals c squared. So the two sides of that triangle squared and added together is equal to the square of the third side. We're going to change this just slightly. So to go to this point x, we would move along the x-axis however many units away that is. We would also move up y units to get to that point, which means in our equation, we're now going to go x squared plus y squared is equal to r squared by taking and substituting those values into Pythagorean theorem. So this is actually the equation of a circle centered at the origin. And we can think about transformations. I haven't shifted this graph to the left or to the right or up or down away from 0, 0. If we had a similar circle, but let's say that it was shifted so that the origin was to the left, and now the center of that circle is going to be some units away from 0, 0. We would have to account for that in our equation of the circle. So rather than at 0, 0, we could say that the center of that circle is at HK, and we would have a point XY, and we would still have our radius. So then when we create our right triangle, rather than finding the distance from 0, 0 to x, now we're only going the distance from h to x. So however many units that those are apart, we would find that by subtracting. Again, we're using Pythagorean theorem, so we would add the distance from y to k, and it would still be equal to r squared because that's the hypotenuse of the right triangle. So two different equations that we need to know. One is for a circle centered away from the origin. The second is from one centered at the origin. So it's important to note that for these equations, x minus hk, or excuse me, x minus h and y minus k, h and k represent the center, and r is again going to be your radius. So we can simply plug in numbers to this equation to help us solve and write that equation in standard form. Standard form, we would have only the variables x and y. We would replace h and k and r to talk about or describe the equation. So for example 1, derive the equation of a circle with center 0, 0 and a radius of 5. So we said in our previous example, if we're not moving away from the origin, we're going to say x squared plus y squared equals r squared. So our equation would be x squared plus y squared equals 25. Anytime you see an equation in this form, you should be able to recognize it's a circle, that our center is at 0, 0 because we're not adding and subtracting h and k, and we take the square root of what it's equal to get the radius. If we have a center at 2, 1, we're going to plug into our equation that translates the circle. Again, this is h and k, and this is r, so we're simply plugging in x minus 2 quantity squared plus y minus 1 quantity squared is equal to 4 squared, which is 16. In number 3, write the standard equation and the general equation of the circle that has a center at negative 1, 3 and passes through negative 5, 5. So this one's slightly different because it does not give us the radius. So if it's the center, then we have h and k. Negative 5, 5 is just a point, which means that's going to be x and y. So we can plug into our equation of the circle. We want to make sure that we see that the negative belongs to the general equation of the circle. So because we're subtracting that -1, that is going to change to a positive. So we want to be careful with that when working with our equations. And this is going to let us solve for the radius. So we're going to change this to plus. So -5 plus 1 is -4. 5 minus 3 is 2. So we square a negative, it's always going to be a positive. So r squared is 20. So all I need is the r squared to write the equation. If they asked you to solve for the radius, you would take the square root of that to actually solve for the radius. But just to write the standard equation, we would plug in a -1 for h, so minus the negative is actually going to change this to a positive. Y minus 3, because that's k, equals, and the plus sign, 1, 1, 2 equals r squared, which is 20. The next part of this is to write the general equation. So this is standard of a circle. General is that long one that we talked about at the beginning. I'm going to erase this so that we can take and work with that equation. So we want to be careful because remember, we square something, that means that we're multiplying it by itself. So I can't just take and square the x and the 1. I actually have to take and multiply these together, which means there's actually 4 terms. Now you might have set up and used the box method when you were learning how to distribute. But again, what we're really thinking about is multiplying these 4 things together. So x times x would be x squared, 1x plus 1x is 2x, and then 1 times 1 is 1. For the y, we would have y squared, a -3, and a -3 is a -6, and then plus 9. These are actually both perfect squares, and we're going to talk about that in just a second. So once you get used to that, you can work through this a little bit faster. And then we want to rearrange so that the squared terms are in the front. X minus 6y. We would have plus 10. But we need this to be equal to 0. So we would have to subtract that 20 to the other side. So all we did was some algebraic manipulations, multiplied that out, looked for like terms, and made sure it was in descending order with the variables, and then made sure it was equal to 0. So that would be the general form. So the graph's the exact same circle, we're just writing it in a different way. Because the other thing that we need to be able to do is to convert from a general equation to a standard equation. And to do that, we have to complete the square. So if it's been a little while since we've completed the square, you may need some review. We'll do that together in class, in our next class. But we'll review it slightly here. So to complete the square, we have to complete with the same variable. So I'm going to kind of take and work this in kind of like reverse order from the last one that we did. So we want all of the same variables to be together. So I have an x squared and an 8x. And I'm going to leave a spot because I'm going to have to complete the square because we said those are perfect square trinomials. So we're going to force them to be perfect squares here in just a second. Y squared plus 2y. Again, we're going to have to complete the square because we can only complete the square for one variable at a time. And I'm going to move that constant over to the other side of the equation. Now it is an equation, which means whatever I add to the left side, I'm going to have to add to the right side. So I'm going to leave myself room to also do that over here on the right side. So completing the square, you take your middle term of the quadratic and divide it by 2 and square it. And that number goes here. But if I'm adding it to the left, I also have to add to the right. So one more time, to complete the square, we take our coefficient on the middle term, divide it by 2, and square it. And that's the number that we're going to add. Because that allows us to factor this would be the same factor 2 times. So if you go back and look at reviewing factoring perfect squares, which we did in our polynomials unit, so it's been a little while, I would have the exact same thing multiplied by itself. And if you notice, all I did was put that -4 and that 1. So if we need to look at factoring, we can do that again. But hopefully you remember some of that from before. And then we would add -2 plus 16 plus 1. -2 plus 16 is 14. 14 plus 1 is 15. And so now we have converted this to our standard equation. So from this, we can very easily tell that the center is going to be at 4, -1. Because remember, the only way that we can get the plus is if we're subtracting the negative. So we always take the opposite sign for the center. And then the radius is going to be the square root of what that is equal to. And if you haven't remembered to add that same thing to both sides, then your radius is not going to be the right value. One more example. This one's a little bit different because our coefficients are not 1 in front of the x and the y squared. And so we have to be a little bit more careful to complete the square. The first thing we're going to do is group the same variables together and move our constant to the other side. But before we complete the square, we have to make this a coefficient of 1. So whatever is in front of the x squared and whatever is in front of the y squared has to be factored out of both of those terms, because it's distributed property, working backwards. So we're going to factor out the 4 from both terms, and then we're going to leave this term here to complete the square. Same thing with 4y squared. Leave some space to complete the square, and then whatever we add to the left, we have to add to the right. Now this is a little bit different because we do have to think about the fact we're distributing this 4 inside parentheses. We're still going to use the same process. We're still going to divide by 2. Actually, I'm going to leave this as a fraction. So 5 squared, we square the top and the bottom. And we're going to make that 25 over 4. Now the reason I left it as a fraction is because when I distribute 4 times 25 over 4, it's 25. Because we're not adding just 25 over 4. When there's that number out in the front we have to distribute, that's actually what we're adding to both sides of the equation. The same thing is going to happen with the y variable. And that should have a y on that. So -10 divided by 2 is -5. -5 squared is 25. But I'm not just adding 25, I'm adding 4 times 25, which would be 100. And then we can start the process of simplification. So remember that when we factor this, on the last one we said, well, we can just take whatever that number is that we squared. That's what our factor is going to be. So this is going to be x minus 5 over 2. Y minus 5. And then we simplify, -16 plus 125 is going to be 9. So we're close. We want our coefficients in front of these squared terms to be the same. If it's a circle, we should have factored out the same number from both terms, and then we're going to divide everything in that equation by that number. So that would simplify. So our final equation would be x minus 5 halves squared plus y minus 5 quantities squared is equal to 9 over 4. So the center is going to be at 5 halves and 5. The radius is going to be the square root of 9 over 4. Both of those are perfect squares. So the radius is going to be 3 over 2.